So let's talk about limiting an excess reactant. छोटा सा concept है, which is limiting an excess reactant. And the concept is that let's say you have a reaction and you add two things. Like I've got NaOH and it's reacting with HCl, and they're going to react together to form NaCl and H2O. Or what's happening is that you've got, let's say you've got 25 moles of NaOH and you've got 15 moles of HCl. The ratio in which they react is obviously 1:1. I mean, the equation is 1:1. Now, can anyone tell me which one has been added more than the required amount? Which one is in excess?
NaOH, sodium hydroxide.
Okay, so it is NaOH. Okay, the equation is suggesting that one HCl reacts with one NaOH. So that means 15 would react with 15. You don't need 25. 25 is too much. It's in excess. It's more than the required amount. Only 15 moles are needed. So is this clear?
Yes, sir.
So that means 25 is in excess. By how much? Like how much extra did you add? I mean, you just needed 15, right?
10 moles.
Okay, so 10 moles are extra. Like you didn't need those 10 moles because the equation suggests that one reacts with one. So 15 would react with a 15. So you just needed 15 moles. You didn't need 25 moles. 10 are going to be wasted. They're not going to take part in the reaction. So the concept is that whoever is in excess, you just ignore its moles. You just cut them out. You don't use their moles. Nowhere in the calculation would 25 be used. And why would it not be used? Because it's not taking part in the reaction in the first place. Is that clear?
Yes, sir.
And this other one is known as the limiting reactant. Yes.
Did we have a lesson yesterday?
No, we didn't actually. There was no lesson. We didn't. There was no lesson yesterday. I just so once again, is this point clear?
Yes, yes, it is.
Achha, so remember, all calculations would be done using limiting reactant moles. And you just have to simply ignore the excess reactant moles. So, for example, here's another question. I've got 2 Na reacting with 2 HCls to produce 2 NaCl plus H2 gas. So there's this reaction that's happening, and what I have to do now is let's say I've got 65 moles of Na, and I've got 100 moles of HCl, and I'm being asked how many moles of NaCl are produced. So can you tell me how many moles of NaCl are produced? Whose moles am I going to ignore?
$65 moles of NaCl.
Okay, so I'm going to ignore these 100 moles because that's in excess. It's 1:1. I mean, it's the same ratio so that means 65 will react with only 65. It's the same ratio. 65 moles are. So only 65 moles are needed. So 65 would react with 65 to produce 65 moles on the other side. So you're going to completely ignore these 100 moles. Okay, they're not the right number. You added more than the required amount. Most of it is not going to take part in the reaction. Okay, is this clear? Everyone?
Yes, it
Yes,
is.
sir.
Okay, any questions? Any questions? Nothing clear? Everything clear, right?
Yes, sir.
Now the next thing is,
Sir, I have a question.
yes.
Sir, if because the ratio is 1:1,
Yeah.
is that why we only use 65? For example, if it was 1:2, then would 65 be multiplied by 2?
That's the second part. I'm coming to it. Okay, I'm coming to it. Is this clear? 1:1 thing. Is this clear? I'm
Yes, sir.
going to discuss the your question now. So this was easy. This was very easy to figure out which one is in excess because the ratio was kind of the same. T gets 1:1. So you obviously knew that 65 would only react with 65. You don't need 100 moles. That's an excess. So over here, things were very, very simple. So what happens now if you have a different ratio? For example, all of a sudden, I'm going to make the ratio. Let's have a different ratio. Like you've got 2 NaOH reacting with 1 H2SO4. And they're producing Na2SO4 plus 2 H2Os. So I'm going to add these moles. Let's say I've got 100 moles of this, and I've got 70 moles of this. Quickly tell me which one is in excess now. Which one is more than the required
100
amount?
moles NaOH.
Remember, more than the required amount. The larger quantity is not usually the one that's in excess. What's the ratio now?
Oh, H2SO4.
You guess I said the ratio is 2:1. So 100 moles can actually take part in the reaction because according to the ratio, 100 will react with how much? Like 2:1, right? 100 will, so 100 are going to react with 50.
Sir, is it because it's the limiting reactant?
So it is the limiting reactant because the reason it's the limiting reactant is because all of it can react. H2SO4, you've added more than the required amount because only 50 were needed. Because according to the ratio, 100 ratio, 2:1, 100 are going to react with 50. So you never needed 70. 70 was too much. That's an excess. Is this clear?
Yes, sir.
So when the ratios are different, things can get very confusing. Okay, because it's much harder to actually figure out which one is in excess. So you're never going to use the excess mole, same thing. There's a shortcut of figuring out which one is in excess, and we're going to discuss that in a short while. So let's make the ratio slightly more complicated. Let's say I've got 3 calciums reacting with 2 phosphoric acids. You remember, equations are always in the simplest ratio. So it's forming calcium phosphate. Metal plus acid produces salt and hydrogen gas. And there would be 3 H2 gas molecules. So I've got 0.56 moles of this. And I've got 0.28 moles of this. Now tell me which one is in excess. Okay, now things are becoming very difficult now. Which one is more than the required amount? Which of the two cannot react completely?
Sir, H3PO4?
So let's think of H3PO4. Let's assume that 0.28 moles are reacting fully. Can you tell me, according to the ratio, how many moles of calcium would react with it? 0.28 divided by 2 into 3. What do you get over here? What is 0.28? I'm just assuming that 0.28 reacts fully.
0.42.
So if it reacts fully, it needs 0.42 moles of calcium. That means calcium is the one that's in excess because you just need 0.42 moles in the reaction. 0.56 is more than the required amount. So the thing is, this is now getting difficult, okay, where the ratios are getting more complicated and the moles are complicated. It's much harder to actually figure out which one is in excess. In this case, it's clearly calcium that's in excess because if 0.28 moles were to fully react, they would need 0.42 moles. So you don't need 0.56 moles of calcium. That's too much. So how do you solve this without actually getting confused?
So
Yes.
what if you do it the other way around? You do 0.56 divided by
I say
3.
if I do the other way around, okay, in that way I can also figure out which one is excess. If I do it the other way around, let's assume 0.56 moles were to react fully. So according to the ratio, 0.56 divided by 3 into 2, what do you get over here?
0.37.
0.37. So that means calcium is in excess because you don't have 0.37 moles. You have a lot less than that. So that means 0.56 moles cannot fully react. Is this point clear?
Yes, sir.
Yes, sir.
Okay, so that's one way, but that's a confusing way. There's a simple shortcut of figuring out because remember the whole purpose of this thing was, the whole purpose of doing this limiting and excess thing was that all calculations were supposed to be done using the limiting reactant moles. You just had to ignore the excess reactant moles. So I just want to figure out which one is the limiting reactant, which one is the excess. So I can use the moles of the limiting reactant and I can completely ignore the excess reactant. So the simple shortcut is, remember, everything has to be quick. Okay, so the simple shortcut without getting without making things too confusing. Take 0.28. Remember, these calculations are meaningless. It's just a trick. Take 0.28, divide that by 2 by its ratio. Take 0.56 and divide it by its ratio 3. Tell me which of the two numbers is bigger. This one or this one? I think you get 0.14 for this. What do you get for the other one?
0.18. 0.19.
0.19. Whoever gets the bigger number, that's the one that's in excess. You ignore those moles. That's it. All calculations would be done using the limiting. All calculations would be done using the limiting reactant moles. Okay, so the simple shortcut is, without going into a lot of detail, take its moles, divide it by its ratio. Take its moles, divide it by its ratios. Whichever number is the bigger one, that's the one that's in excess. That's it. You just cut it out. Don't use that number in your calculations. Is that clear?
Yes, sir.
Okay, I can apply it over here as well. Like take 100 moles, divide by 2. Take 70 moles, divide by 1. Which one is the bigger number? 100 divided by 2 is 50, 70 divided by 1 is 70. This is the bigger number, that's in excess. You cut it out, okay? Don't use that in your calculations. Is that clear?
Yes.
Yes, it is.
Okay, so it's a simple shortcut, just use that shortcut. Don't go into a lot of detail. Let's try another one. You've got 6. Let's do this one. So I've got this equation, which is P2 plus 2 P2s plus 5 O2s. And it's forming P4 of O10. Okay, I've got 0.60 moles of P2, and I've got 1.7 moles of O2. Quickly tell me which one is the one that's in excess. Which moles should be ignored?
The 1.7 moles should be ignored.
The 0.6, take 0.6 divided by 2. Take
And
1.
it's 0.3.
This one is
Oh, okay, 5.
This one is 0.3. What do you get for this?
0.34. 0.34, yeah.
So that's the bigger number. That's the one that's in excess. Just cut that out. Don't use that. Okay. And you can even confirm this. I mean, find out the ratio 0.6 divided by 2 into 5. What do you get? 0.6 divided by 2 into 5. That will give you 1.5 moles. That means for 0.6 moles, what do you get? 0.6 divided by 2 is 0.3. 0.3 into 5.
Yes, sir, 1.5.
Yeah, it's
So-
1.5.
So that means you just needed 1.5 moles. You never needed 1.7. That's in excess. Okay. So just remember, whoever gets the bigger number, you just cut it out. Don't just remove it from the calculations. Don't use that. Okay, is that clear? Let's
Yes, okay.
Yes, sir.
so let's do another one. Okay, we've got 6 LOH plus 3 Cl2s, and it's forming 5 NaCls plus NaClO3 plus 3 H2Os. So I've got 2.25 moles, and I've got 1 mole. Which one is in excess? Cl2 or NaOH?
Cl2.
What's 2.25 divided by 6? What's 1 mole divided by 3? Which one is the bigger?
2.25 divided by 6 is 0.375. So 0.38.
So 0.375, 38. So take 0.38. And this one is 0.33, right? So this is the bigger number. That's the one that's in excess. Okay, so all calculations would be done using the moles of chlorine. Is that clear?
Yes, sir.
Yeah, it is.
Okay, and remember, the task is to do things quickly. Okay, you have to be very quick. So use these tricks. So in this question that we were about to do, this was about gases, but it was actually a limiting and excess reactant question as well. For example, he's saying propan-1-ol. You can write down the equation for propan-1-ol, which is, I think it's getting burnt in oxygen. So that's C3H7OH getting burned in oxygen, and it forms a carbon dioxide and a water molecule. So 3 CO2s, you got 4 H2Os, and you have what? 6 plus 4, that's 10. So over here, you'll have 4.5 O2s. Okay, you need 9 oxygens over here. There's one, I mean, you need a total of 10 oxygens over here. There's one already here, so that you need 9. So you would multiply this by 4.5 or 9 by 2. So anyways, I've gotten the ratios. Now the question is, he's got 0.1 moles of propanol, and there's 12 dm cube of oxygen. Remember, it's room conditions. So what's 12 dm cube of oxygen? How do you find the moles? 12 divided by 24, right? So how many moles you've got? You've got 0.5 moles.
0.5 moles.
So he's added both things. Now quickly tell me which one is in excess. 0.1 divided by 1, that would be
Oxygen.
okay. So 0.5 divided by, it was pretty obvious as well. Like 0.1 will react with 0.45, 1:4.5. Or you can do the division thing. 0.1 divided by 1, 0.5 divided by 4.5. This comes out to be the bigger value. So all moles will be calculated using this one. That's the one that's in excess. So you can now use ratios. How many moles will react? 0.1 divided by 1 into 4.5, that will give you 0.45 moles. 0.1 divided by 1 into 3, that will give you 0.3 moles. And 0.1 divided by 1 into 4, that will give you 0.4 moles. So you're,
Sir, shouldn't you check what's in excess using like the volume ratios? Because like in the final one, you have to add the excess to the CO2 that's going to be left as well. Because it added, it says, like, final volume.
but the thing is, you can't remember the volume ratio thing I told you was only applies if you're comparing gases. Propanol is not a gas.
Okay.
Okay. I mean, you can do that for the volume thing only if they're gases. Okay. Acha, so anyways, he's asking what is the final volume of gas at room conditions. So carbon dioxide is a gas, so you can find the volume. To find the volume, you multiply by 24 dm cube. So how much do you get? 7.2 dm cube, right? So you get 7.2 dm cube. Water is not a gas at room temperature, so that's out of the question. What other gas would be present in the mixture? What would be the final volume of gas? Would it only have carbon dioxide? Would it have something else as well?
0.05.
Okay, there's leftover oxygen as well, because remember you added 0.5 moles, but in the reaction only 0.45 are taking place. So that means 0.05 moles of oxygen is left unreacted. And you can calculate its volume by multiplying it by 24 dm cube.
1.2 decimeter cube are left.
Are left. So you had, as a product, you had carbon dioxide, which was 7.2 dm cube. Plus there was some leftover oxygen as well, because not all of it reacted. It was in excess. Only 0.45 reacted. 0.05 was still left at the end. And their volume is, if you multiply by 24, you get 1.2 dm cube. So you add them up, the final volume is going to be 8.4 dm cube. Okay. So is this question clear?
Yes.
I mean, this was a difficult question. The reason this was a difficult question was that most people, because it had limiting in excess, I mean, you had to figure out whether to use 0.5 moles or 0.1 moles. Okay. So we figured out that this is the limiting reactant. This was the excess. We just cut it out. All moles were calculated using this one. That was the first difficult part. Then most people would assume that you were just looking for the volume of carbon dioxide gas that's produced, and they would kind of ignore the leftover oxygen. So they would see 7.2 and they'll circle 7.2 when the actual answer is 8.4, because there's some leftover oxygen. This was in excess. So this was a tricky question. We're done with moles and gas questions, and we did the limiting in excess as well. Now, this is about empirical formula. We're going to talk about, I mean, empirical formulas are kind of easy. Moles, let's do moles and number of particles first. Okay, let's do moles and percentage. That is. So now everyone must know what empirical formulas are. I'm assuming everyone knows that. I can add that to this. Like, how do you find empirical formula? What's the 2 steps? Just a second. If you remember those 2.
Is it the simplest ratio of
Yes. So the empirical formula gives you the simplest ratio. That's the simplest ratio of atoms in a molecular compound. In a molecule. So how do you find the empirical formula? For example, in this one, where's the question? So for example, in this one, he's saying that there's an oxide, but you forget that. Let's do an empirical formula question. That's too long. Let's see, 1 second. Where are all the empirical formula questions? Just a second. Is there? I mean, there was one there, but let me just quickly open another one. Just a second. Moles, this one. Okay, let's just take a couple of questions from O levels. These were very easy. So empirical formula. Now in empirical formula, you'll be given the mass of substances. Okay, let's take this. You'll be given the mass or the percentage mass of the elements in a compound. For example, this one. So for example, this one, there's a compound that's got potassium in it. And they've given us the mass of potassium. It's given as what, 5.547 grams. This could be in percentage as well. You're given the mass of iron, which is given as 0.195 grams. And you're given carbon as well, which is 0.252 grams. And you're given nitrogen as well, which is 0.294 grams. Now tell me, what's the first step? How would you find the empirical formula? You've done this frequently. What's the step? What is step one?
Calculating the moles.
What's step one? You divide by, I couldn't
The
hear you.
smallest number.
21.
Now you find the moles first, divide by the AR. Moles is mass divided by, you have the mass, you divide by the AR. You find the moles, 0.547 divided by whatever potassium is. I'm just going to look at the data booklet. I'm just going to divide by 39. 0.195 divided by what iron is, 55.8. 0.252 divided by carbon, what's carbon, 12. And you've got nitrogen, which is 0.294, and that's going to be divided by 14. So that's the first step. You find the moles. So what do you get for the first one? Can anyone calculate all of this? What's the first one? Can you all hear me? The first one.
Sir, 0.014.
That's a 0.043, 42.
14.
14, sir, 14.
Yeah, I didn't get it. 43, right?
14. 14.
414.
14. 14.
0.014. This thing, right?
Yes. Yes. Yes.
Acha, what about the next one?
Sir, 0.0035.
The next one. I think it'll be,
Sir, 0.021.
and the last one, it's going to be the same.
Just the same.
Yes, sir, it's the same.
Acha, so you found the moles. Now you found the number of atoms, right? In moles. You've got these many moles of this, these many moles, these many, right? Now you have to find the simplest ratio, like how a whole number ratio. So what you do is you pick the smallest and divide everything by the smallest. So it's going to be divided by 0.0035, I think. So that's the second step. You divide everything by a 0.0035. So that's that's step one. And your step two is divide by the smallest. So what do you get for the first one?
4.
So you're gonna get 4. This is obviously 1. What is this? 7 or what?
6.
You're
It's
getting
6.
So these two are 6. So that means your empirical formula, or the simplest ratio of the atoms, is there are 4 potassiums, 1 iron, and there are 6 carbons and there are 6 nitrogens. Okay, so remember this, that empirical formulas, these are the 2 steps that you got to perform. Step number 1 and step number 2. Okay, is this clear?
Yes.
Achha, now about empirical formulas. A few things. A lot of times the last step, divide by the smallest doesn't always give you a whole number ratio. Okay, for example, if you divide by the smallest, like you got, for example, you got two things. You had carbon and hydrogen, and you had, let's say you got 8 moles, and you got 6 moles of this. If you do the divide by the smallest thing, what's 8 divided by 6, and this one would be 6 divided by 6 as well. What do you get for this? This would be 1.33, right?
1.33, yeah.
I mean, 1.33 would be the ratio, 1.33, and this would be 1. So the point is that if you divide by the smallest, a lot of times dividing by the smallest would lead to the simplest ratio. Like if you're getting this ratio, you divide by the smallest, you pick 2, you get 1:5, right? So that usually gives the simplest ratio, but not always. Not always is it going to give you the simplest ratio. You've got 4 and 6. You divide by the smallest, you'll get 1 for this. This would be 1.5. Again, you're not getting the simplest ratio in whole numbers. So the point is, what would happen if the ratio at the end is something like this? Like you're getting 1.33 ratio 1. What would you do in that case when the ratio is not coming out to be a whole number? So you're going to try and convert that into a whole number. Okay, so for example, you're getting this ratio. So you're going to think of numbers to multiply both with, so that it turns into a whole number. First thing is, and you can try. You can do trial and error. Or if you see 0.33, you can kind of guess that if I multiply this by 3 and I multiply this by 3 as well, like 1.33 getting multiplied by 3 would be something that would be very close to 4. I mean, you can try this on this calculator, and this would be 3. So it's basically 4:3. Is this clear?
Yes.
Yes.
Achha, let's say it's, what about this one? You got 2:1.667. So think of a number. I mean, your ratio is not a whole number at the moment. So what would you multiply both with? So this becomes a whole number. You can try and do this you can do trial and error. Like if I multiply this by 2, that's 3.
Yeah, 3.
Let's multiply both by 3. So this comes out to be 6, and this comes out to be what?
It comes out to be 5.
It comes out to be 5. So, and similarly, what would be this thing? If you got 3:4.5, that would be easy. What if I want to convert that ratio into a whole number? How do I multiply? What do I multiply each with?
By 2.
Okay, so it would become 6:4.5 into 2 would be 9, right? So just be careful when the ratio that comes at the end is not a whole number. So think of a number that you can multiply it with, so that both become whole numbers. And you can just do trial and error for that. Okay, is this point clear?
Yes, it is.
So here, let's continue tomorrow. There's one more point about molecular formulas. If I missed that, remember, remind me to discuss that. And tomorrow is face-to-face class, right?
Yes, sir.
Okay. So here, let's continue tomorrow then.
Okay, sir.
Okay, take care. Allah Hafiz.
Allah Hafiz.